Fusion Mobile, quality e-learning experience on the go.
Okay, you're welcome to yet another biological class. I am Olajide, and this program is powered by Fusion Mobile e-learning clinic. We are always for you. We're there for you. So supporting tissues in plant is the topic at hand. We're going to be looking at the supporting tissues that are present in plant. As the name implies, supporting tissues, their major function is to support the plant, to strengthen the plant, to give the plant resiliency, to help conduct food materials in the plant. There are basically three. Okay, it's actually more than three. Okay, for the sake of this class, I would actually like to go low. It's as if I'm having the kind of adrenaline rush, sort of. So there are basically 5 types of supporting tissues, but there are 3 major supporting tissues, but we have 5 types. Anyway, we have the parenchyma, we have the cholenchyma. The name is sounding American, sort of. We have the sclerenchyma, we have the xylem, and we have the phloem. What is the parenchyma? The one thing you need to know is that the most abundant of all of them is the parenchyma. The parenchyma is living. It is living. It is actively dividing. It is like the act of the supporting tissue. It is the act of the supporting tissue. Are you here? So the parenchyma is found in the cortex of stem. It's found in the cortex of stem. It is found in the phloem. It is found in the root as well. It has thin wall. It contains large vacuoles. That means the parenchyma can store food. It contains large vacuole. So what's the function of a large vacuole? For food storage. Basically, it is common and the most abundant. It stores food and water, and it gives the plant rigidity, firmness, as the case may be. What is a cholenchyma? One distinctive feature of a cholenchyma is that it helps in flexibility. When you touch a plant and the plant can easily bend this way, that part is called the cholenchyma. So it helps in flexibility. And that's why most time when you detach a leaf, when you detach a leaf from a plant, you remove the leaf. That part is always somehow it is succulent. You can easily bend it, sort of. So that's the cholenchyma. The cholenchyma is found in the cortex of stem and the hypodermis. What is the hypodermis? The hypodermis is the part below the epidermis. The word hypo means below the epidermis. It is living and elongated. Most people actually say the cholenchyma is living at maturity. That when they mature, they are living. But one thing you need to know is that they are living. Whether at a particular point in time or so, they are living. They have unevenly thickening. Are you hearing? Unevenly what? Thickening. That's one of the distinctive features of cholenchyma. If, for example, now this is a cholenchyma, are you hearing? They have unevenly thickening. What do I mean by that? It means they are not thin all through. It means at a particular point in time, you notice a kind of thickening, a kind of dot stuff at the edge. At the corners, you notice dots. At the corners, you notice dots. It is not just thin to the end. No. They have unevenly thickening, and these thickening are not well shared. They are not well positioned. So that means it is uneven. It is not just thick all through. No. It means at a particular point it is thick. At the particular point it is thin. At the particular point it is thick. That's why we call it unevenly what? Thickening. So they have unevenly thickening. They are there for flexibility. They provide strength. They are found in the petioles. Petioles is also called leaf stalk, as I've explained earlier. And they are found in the leaf blade. The leaf blade is this margin, the margin of the leaf, this edge. It's called the leaf blade. Now we look at the sclerenchyma. Sclerenchyma contains dead cells, cells that are dead. They contain dead cells. Their cell wall is thick and lignified. Naturally, the cell wall of parenchyma contains cellulose. But that of sclerenchyma has in addition lignin. Lignin is a carbohydrate substance. It's very, very strong. It helps to add energy and strength to the cell wall. So the sclerenchyma is found in the pericycle of vascular tissues. What are vascular tissues? Vascular tissues are xylem and phloem. We'll still get there. So they are found in the pericycle of vascular tissues. They are found in the cortex of root and stem. What is the cortex? Okay, so as I said earlier, the cortex is found in between the epidermis, which is the outer covering, and the vascular tissue. So the cortex come in between. The cortex of root and stem. They have thick wall, as I've said earlier, cellulose and lignin. Are you with me? Now the sclerenchyma is made up of 2 major parts. We call them the fibers and the sclerids. The fibers and the sclerids make up the sclerenchyma. The fibers and the sclerids make up the what? The sclerenchyma. Now the fiber is elongated and it has tapering end. At the end, it is tapery nature. Tape like tape. Tapery. That's tapering end. One thing you need to know is that they are elongated. It has elongated cells. While sclerids, they are not elongated. That's one major difference between the fibers are elongated. Sclerids are not elongated. And their major function is rigidity and firmness. Let's look at xylem. Xylem is also called wood tissue. Xylem is called wood tissue. The xylem is a vascular tissue. It is a vascular tissue itself. It is found in the vascular tissue of stem, root, and leaf. So every part, the stem, the root, and leaf, has the xylem. The phloem is also found in the stem, the root, and the leaf as well. The xylem and the phloem make up the vascular tissue. The xylem is subdivided into 4. The xylem is subdivided into 4. They are the trachea. These are the parts that make up the xylem. The trachea, the vessels, the fibers, and the xylem parenchyma. So based on my explanation thus far, you can easily say that the xylem parenchyma is living. Based on the explanation, whenever you see parenchyma, you know it is living and it stores food. So you can say the xylem parenchyma is living and it stores food. So the trachea, the vessels, and the fibers are the other part. Fiber, as usual, is what? Elongated with tapering end. It's very, very easy to get it. It's still the same thing, but they just have different fibers. Different fiber. That's how we call this one. We call this xylem fiber. It is not sclerenchyma fiber. We have fiber for sclerenchyma, we have fiber for, but they are still the same. But they have organs. They have bosses that they are answering to. So that's where it is. So now for phloem, the phloem is also found in the vascular bundles of stem, root, and leaf. The phloem is made up of 4 major parts. They are the sieve phloem. Sieve phloem. What's the function of the sieve? They act as a sieve. Sieve phloem. Recall, phloem carries what? Food materials. Xylem carry water and what? Mineral salt. So the phloem contains the sieve phloem. They contain the tube parenchyma. So that means it is what? Living. It is what? Living. Sorry. It contains the phloem contains the sieve tube. The sieve tube. Sorry. The phloem contains the sieve tube. It contains the phloem parenchyma. Phloem parenchyma is living. The sieve tube help to connect. That's their function. As well, we have the plasmodesmata also, but we're not going there today. The vascular bundles also contain the phloem fibers, and lastly, it contains the companion cell. And we're going to be looking at some terms briefly. What is the meaning of epidermis? Epidermis is the outer covering of the stem and the leaf. Recall, a plant has 3 major parts: the stem, the leaf, and the root. So if the epidermis is the outer covering of the stem and the leaf, what then is the outer covering of the root? The outer covering of the root is called the piliferous layer. The epidermis is the outer covering of the stem and the leaf. That of the root is called the what? The piliferous layer. Never forget this. It's called the what? The piliferous layer. And so we have the cortex. The cortex is in between the epidermis and the what? The vascular tissue. It's in between the epidermis and these two. In between the epidermis and what? These two. Don't forget. It's found in between the epidermis and these two. We have the cambium. What is the function of the cambium? The cambium is responsible for secondary growth. The cambium is responsible for secondary growth. Secondary growth. What's the meaning of secondary growth? Secondary growth simply means secondary thickening. It means addition of extra mass to the mass of a wood. When a wood is a mass, is increased in size. Are you with me? I will call it for secondary growth. And what's responsible for that? It is the cambium. The cambium is responsible for that. As a matter of fact, the cambium is also found in between the xylem and the phloem. It differentiates the xylem from the phloem. If I have xylem and we have phloem, the cambium differentiates them from one another. Lastly, we have the pith. The pith is the center of the plant, the center of the stem, or the center of the plant, as you can call it. But I think stem is actually better. Now, one thing you need to know is that cortex is found in a dicot plant. It's not in a monocot plant. And secondary growth is seen in dicot, not in monocot. So whenever you hear a plant has cambium, that plant must be a what? A dicot and not a monocot. So don't mix it together. So then what are the uses of fiber? They give strength to the plant, they give resilience to the plant, they help in conduction, rigidity, and also give distinct shape. I'm sure you enjoy this class. Some questions will pop up on your screen. I do the needful. I love you.